Okay, this is Ashwant. I would like to get started on attempts to building a database. I came across someone's tweet recently, and this kind of reminded me of a few things that we used to do earlier, a few years back. So this is my attempt at trying to build a very simple database. I think this is going to be more of a series rather than a single video. I don't even know if I would be able to complete it, but let's see where it goes. Okay. I think one of the easiest things to get started is to build a key value database, right? So let's do that. So let's build a KV store, right? I'm gonna choose Java because I'm kind of familiar with the syntax. It's gonna uh, get it's easy. It's a little verbose, but with the new features and all, it's relatively easy. And I think the learnings that you will probably have, or as I try to build these things, would be something that should be transferable to any programming language, right? And not necessarily just tied to Java. Okay, here we go. Awesome. Okay, we have ourselves. Thank you. We have ourselves a project to work with. Awesome. We'll update these dependencies, but let's get started. Okay. Um, I'll just delete the existing code, create a package, KV store, and we're going to start off with defining how our database is going to be. We said it's going to be a key value store. Let's start with simple things like you need to be able to put a string key and a string, value. I don't want anything back in return. And then I would need a get where I can get a key. Now, this is interesting. Get may or may not return a value because if the key exists, it exists. It might give you a value. If the key doesn't exist, it'll probably give you a null. Um, let's put it as optional. And there we go. Oh, what's the problem? Oh, I need to set the language to 1.8. Okay. And let's also put a simple method that says contains, right? Yeah, very simple interface that allows you to write data, read data, and then check if the data exists, right? So let's start with an implementation. So a very simple or rudimentary implementation for the key value databases are when you can just store them in memory, right? So I'm just gonna call this as in-memory store. I'm gonna say implements store. Now we all need a backing for this. So I'm just gonna use a map. Oops. A concurrent hash map, which kind of, has this as the underline. Um, we'll improvise this. Okay. Put is basically doing underlying dot put of key comma value. Get is nothing but underlying dot get key. Contains is nothing but underlying dot contains key. Okay, we now have our simple in-memory key value store. Now we need a way to access the store. So let's build an API for this, right? This is going to create a package called API. I think this kind of makes a package called core. We'll move the in-memory and store to the core. We'll need something for the API. Okay. I'm just gonna go look for, pick up this framework, Spark, Java, Maven. Got it. This should, yeah, published long ago, but I think this should help us with the stuff that we are trying to build. I mean, I'm just trying to put a simple HTTP server in the front. It says, okay, so Jetty HTTP has a vulnerability for this version, okay? This is the only version that doesn't have it. Let's see if adding it here helps. Seriously. I don't even know if XML exists. Oh, it exists. Okay. Awesome. I'm just going to quickly take this to say Jetty version, replace. Perfect. Okay, I'm just going to create a class called application, C-A-T-I-O-N. You probably need a main method, and I'm just going to quickly copy paste this guy. Okay. Perfect. Okay. So let's just run this guy and see how it works. Oops. Okay. These, they just don't work, do they? Okay. You're supposed to add this and you're supposed to work. That was the contract. Let's, okay. I'm just gonna remove this. I know this is bad, but I would rather focus on getting a version out and then fixing this. Okay. Uh, it's really bad to see this guy. And then Lockback Classic, Lockback 1.47. And I always search for example XML. Oh, nice. It's there in my book history. I love this guy. These are extremely good, ready to use files that I probably copied from his website like a million times. Um, Maybe I'm exaggerating a little bit more like 500 times. Okay, so change this to info. Perfect. And then let's rerun. It still fails, but it's okay. What's the endpoint? It says hello. Let's say hello. It doesn't even tell me what port this guy runs on. Okay. Oh, it's 56456. Okay, that's the port. I was in the wrong port. Got it. So I'm gonna have a get request dot As a query, yes. Wait, can I use path? No. Request routes. Routes. Oh, yeah. There's patterns. Okay, this is what I wanted. Okay. So you say key. So you say key equals request dot pattern key. For Christ's sake, I'm in 18. Why don't you just put me on 18, please? Uh, okay. Moving back. Okay, am I supposed to return something? It has a route. A route is supposed to return something. Okay. For me to work, I need access to a store. It's gonna create an in-memory store. Have this, and then return store dot get the key. Oops. And I just return that. Perfect. So let's just quickly restart. Okay. How does this not exist? So I say get key. It gives me optional.empty. Okay, just returns it to a string. Brilliant. So I just need a what response dot body, or is there a cookie header status raw type? Huh. This is much harder than I thought. Okay. Um. Oh, seriously. Hmm. I'm seriously questioning my life choices at this point. Should have probably gone with Spring. So much boilerplate, but it should still work. Okay, I'll give this one more shot, and then yeah, probably switch to Spring. Okay. I'm gonna need. Is it core that I need? Not sure why. Anyways, okay, and it says, hey, create a JSON transformer. Okay, I'll create one transformer. Okay, thank you. Import. Okay, so yeah, I delete this followed by new JSON transformer. Perfect. Okay. I now have the ability to get something. Let's see if this guy works. My SLF4j is not able to pick up my log4j for any reason. So we'll kind of get to that. Okay, okay. And you still won't tell me what is the problem. The easiest way to check is perfect. Please tell me you've added. Yes, thank you. Um Just JSON transform for optional. So it should ideally return me an empty string. Okay. Where are you? Where are you? Yes, I don't want this. Okay. Those are the files from the auto-generated code. Um, okay, now we are getting into the world of JSON. Um, Optional type adapter. Oh, they want to support 1.6. Awesome. Okay. Oh, okay. Um, does that mean you also provide what is this? Okay, we are digressing a lot. Coming back, I got a useful gist here. I don't want optional.java. I want the type adapter. Ah, nice. Seems more like it. Okay. Welcome to the world of Java. If you're looking at this for the first time, please do not try this at home. You want to reserve credits? Thank you, FDIL. You're helping me get this video out. Thank you. Okay, let's try again. Oh, wait, I need to be able to specify this adapter somewhere. I'm guessing using optional just located elsewhere. Oh my god. Okay. Um, this is kind of turning out to be slightly embarrassing. Is there a register? Is there a adapter? String, atomic integers, URL, bitsets, sequels, classes, JSON. Okay, this is brilliant. So where do we use this? Oh, you don't know where do we use this. Why am I not surprised? Double adapter. Where are you using this, please? You say factories. What are factories? Needs to be able to type. Oh, I need to use that for the builder. Okay. Builder. JSON builder now is great. Awesome. Say register type adapter. That's what this guy was. Um, type. That's this type is what type? This is java.reflex.type. Okay. Class. Nice. So I should be able to say class of optional dot this. That's one way. Or this empty dot get class. That should do the trick. Okay. Do you work? Actual is null. Ha! It's returning a null, which means this guy is probably returning a null. Okay. Okay, so he's actually storing the value, else he's storing null, because you can store null, and when it serializes, it returns you back null. Okay, which means I'm looking at assert null. Oh, okay. It's null of type string because it's JSON. Okay, perfect. Moving back. Okay, now that everything is set up, it returns null. Brilliant. Okay, awesome. We got a get API working. Yay. Let's put right a put just a put key body is value, key becomes request dot parents dot key. You do a store dot put of key comma value, and then you say okay. This might be a little hard, so I think I'll probably just use Postman. To create a request. Okay, so what we want is this guy, but instead of guess, get its put, and it's also put raw. Yeah, it doesn't matter. You just say value by sending. He says okay. If I refresh this, it gives you the value. Awesome. This is what we're looking for. Perfect. Um, okay. Is there a way to I don't know. Okay, this should be null. I send the value. This should now be value. Huh, interesting. What I'm looking for is what's the return type like? It's giving me application.json. It still doesn't render as a JSON, which is very weird. The same goes here. Okay, so I just replace this with get. It does detect, but okay, because I just return strings, which does make sense, right? So yeah, I mean, this is kind of one way that you go about building a very simple in-memory database. But there is a catch. The catch is every time we go and restart this guy, I go get the value is lost. The value is lost for the key that we just entered because it just stores it in memory. And whenever we restart the application, all the data from the memory is gone, right? It just isn't scalable, or it's just not persistent. But we want to be able to persist the records so that we are able to retrieve it back whenever the system restarts or the process restarts, right? That's like a bare minimum thing we expect out of databases nowadays. If you can't, if the data is not durable, like what's the point of me even storing that using the database, right? Makes no sense. So there are multiple ways we can do the persistence. I'm going to start off with a very, very simple approach. And that approach is to basically use something called as a WAL, WAL. It's expanded into write ahead log. The idea is every time we get a request, say for put, which is going to modify our database, we're going to write that key value entry into a file. And then whenever we load the store, we're going to populate our in-memory store from that data, from the WAL file, so that I can now start serving the requests, right? I mean, of course, there are multiple steps, each along the way, each having the trade-offs, but let's start by writing some basic simple things and then kind of take it up from there. Okay, I'm just going to create a package called IO. Inside that, I'm going to create a file called as a class or a record called as a WAL record. The idea behind WAL record is it's going to store an action, which I think is better spent as stored as enum. We're just gonna say it as add or put if you want to make it. Now, why did I create this action? Today, we do not allow deletes in our database. If you see, we only have get, which is reading, put is writing. We say contain, which is like checking if the value exists, but you don't have a delete. At some point, we will want to support deletes as well. So at that point, your enums will have multiple values. So that's the reason for having an action. So we'll start off with an action, which is most likely going to be just put, and then followed by a key and then a value, right? We're going to persist all of this information into the file. Okay, and this is what a wall record is. So I'm just going to create another class called as wall rather file, right? It's going to have, let's say outputs. It's going to have an output stream. I have a wall stream. Um, just going to make it final so I can initialize this in the constructor, but ideally I don't want to initialize it there. Instead, I would want to create a wall file with a random name, which we're going to identify that using an extension called as wall. And I'm going to assume all of the files will be written on the current working directory. We can eventually support for a data directory. We're going to start off with this, and then I'm just going to say print writer. Yeah, a new file output stream becomes a wall file. This is going to throw an error. I'm not so much worried about it. Yeah, I ideally need a writer. Just call it as writer. You're going to enter a wall file. Okay. Okay, this is redundant. So I'm just going to say void record a record. Right? So writer needs to write a string, but for you to write, you're going to need something to work with. So let's just say I'm too scared to create this file, but I don't have a choice. And that's what I'm going to tell myself and proceed on to do this. Okay, so you're going to need two JSON. That's going to just take an object. That's going to be input. Return json.toJSON, which is going to be input. You're going to have, yeah, deserializer. I don't think so. We'll add that a bit later. Oh, nice. Oh, this guy is not static. I didn't realize that. Perfect. Okay. So I'm just gonna say JSON utils.toJSON, convert it to a record. Yeah, you'll likely throw. That's okay. And then as soon as it's written, I'm gonna flush. This flush is extremely important because typically when you write, the data is usually written to a cache, not to the disk. Flush is when you actually write it to the disk. And wall file, this file will kind of be active throughout the lifetime of our application. So every time we add a record, it's gonna keep writing and flushing it. We'll never actually close this file explicitly. So my in-memory store will now have a wall file. Awesome. Okay. Wall file equals wall file. Perfect. Now that we have a wall file, before I do a put into my system, I'm just going to say wall file.record, a new wall record. Action is put, key, value. Oh, this record cannot throw exceptions because that's gonna violate my contract. Okay, I'm just wrapping it inside a runtime exception, so I fail at runtime rather than these compile time errors. Okay, perfect. So just gonna keep writing it. Let's just quickly run this and see how our little guy works. Get still returns a null as expected. Put has now says okay. So ideally now I should have a file, nice, called .wall. If I open this, you can see one record being created. Awesome. So let me put a key, oops, key 2, value 2. Ha, this is a problem. So we are kind of writing it without much record boundaries. This is going to be relatively harder. I think we should change this to like a println. Change this guy to println so he gives me a println. Oh, nice. So these guys handle the exceptions automatically. Pretty sweet. Um, even do you still throw? Okay, you still throw. Sure. So basically, inside the in-memory store, we still store this. I go back, I delete the file, I restart. Perfect. I'm gonna do a put, see a file create, see a value here, change that to key and value. Voila. Now you have individual lines. Should be easy to parse, right? Awesome. Now we are able to persist. But if you see, if we do restart, the get would still give you null because we are not essentially reading or utilizing the wall file that we have. So what I'm going to do is go back to the wall file and then say um, wall file reader becomes a class um, where the idea is you still have buffer reader, wall file reader, right? That's the final. So gonna start with the constructor. I'm just gonna replace this with rather a list of string. I don't want this one, I just want list of strings. Wall files on disk. Yeah, linked list is more appropriate. So we're just gonna do a new file of um, list files, new file name filter, you say name dot ends with dot wall. Yeah, make this smaller and nicer with lambda. You say wall files equals this. So this dot wall files equals arrays dot list of that's the problem. Okay, equals now. You say new linked list else this. Hmm. Becomes a redundant initializer. Okay, so this is gonna give me a wall record. Say read. Um, or rather in this case, a stream. Okay, so I'm gonna take all the files, convert it to stream, map on each one of them, which means I have a file name. I'm gonna convert that to a buffered input, buffered reader. I'm gonna need file reader, got it. I'm gonna have passed the file name, perfect, okay. Yes, sir, perfect. Once I've mapped all of them to the reader, I'm gonna take each reader and then give you back to essentially do a flat map, give you back so I get reader dot lines, which is effectively every line across the reader. Right? It's gonna just flatten them out. So now that I have every line, I'll use this. Now I'm gonna need the JSON utils from JSON. Perfect. So this is ideally going to be T passed by T, say from JSON, passes from JSON. JSON followed by okay, plus awesome. So I'm effectively going to do JSON utils start from no, I can't. Rather, this is a line dot line wall record dot class. This is what we want. Okay, perfect. Now I'm effectively returning a stream of wall records, right? So I'm going to use this wall reader and come to the in-memory store. Before I initialize this, I'm going to do a wall reader. So this wall reader dot read is streaming me records. I'm gonna for each on them record. Just gonna say if record dot action equals wall action dot put, which is the only option that we support. I just say underlying dot put of record dot key and record dot value. That's it, right? Now that I've read everything, I have access to everything. Now I just go about to say public boolean deletes all files on disk. So at this point, I'm just going to go over them, do a for each file, then say new file dot file dot delete. Yeah, I don't want the result. This is good. Where is my store? So once I've done, I'm just gonna say wall reader dot delete all files on disk. Okay, perfect. So now when we have, before we start the program, we have two files. One file has a couple of records, another file is effectively empty. So let's see what happens. Oh, all match, which means I'm gonna return a boolean, which means this is return. As you see, both the files are deleted, just got replaced with one, nothing, no file, because the wall file doesn't or creates this only much later. So I think we're okay. So let's go and ask for the existing key. Nice, key 2. So this guy should keep on existing in our system, but there is a fundamental catch. The catch is because we are deleting all the files, um, it will work only the first time you do a restart. The second time you do a restart, because we have deleted all the wall files, there isn't any way to retrieve this data, so it'll always be null, right? So one possible way is to make sure we don't delete these files. Um, that way you'll just have the wall files lying around, and we are anyways reading all the wall files and then repopulating our in-memory store with those records. So it should, I mean, now it should still say null. It should work. Like I just put to, say, replace this with 3. Now I have 3 keys. So key 2 and the key 3, right? All 3 should be part of this wall, the newly created one. No harm done. Restart the process. The wall still exists. Values still exist, right? But the catch is you're gonna keep creating a new wall file each time you restart. Typically, you don't restart your database like every other minute or every other hour. So this approach should be okay for now. In the next video, or the next video in the series, we'll talk about, hey, is there a way we can optimize this, have a better layout, and then also start supporting deletes, right? When we want to support deletes, how will they work in our whole scheme of things, right? So yeah, until then, this is my first attempt at building something like this. So if you have any thoughts, feedback, any questions, any suggestions on how this whole medium of delivery can be improved, or things that you didn't like in this whole video, please share them, and I'm happy to take the feedback and kind of work on it the next time. See you folks. Bye bye.